We'll get started in just a few minutes. We've got a few folks coming in. We'll get started in just a couple minutes. Camille, is everything okay with sound? And you can see
hear you.
Perfect.
Yeah, I can hear you and see the presentation.
Okay, great. We'll get started in probably about 30 seconds. Great. Well, I think that we probably have everyone here that has time for the presentation tonight. Welcome, everybody. You are here for the Water Environment Services Tri-City Outfall project presentation. We're glad you came tonight and took time out of your evening. My name's Kristen Kibler, and I'll be the facilitator for the meeting this evening. The event is being recorded. We'll be putting this on the website after probably next week. Microphones are muted. This is a webinar, so you can see us, but we can't see you. So if you would like to eat dinner or whatever, you can go ahead and do that. We can't see you and we cannot hear you, so don't worry about noise. And then we are going to give a 30-minute presentation today, and then you can use the chat function to ask questions, but we will wait until the end of the presentation before we get to those questions. And we'll go ahead and do some introductions and then get started. So first of all, let's go ahead and meet the project team. As I said, I'm Kristen Kibler with JLA Public Involvement, and I'm here helping with logistics for the meeting today. And I'll pass it over to our staff from Clackamas Water Environment Services. Greg, you're up.
Hi, everyone. Good evening, and thank you for being here. My name is Greg Geist, and I'm the director of Clackamas Water Environment Services. And Jeff, do you want to go next?
Sure. Good evening, everybody. Jeff Stallard. I'm the Capital Program Manager at Water Environment Services, and I've been managing the Tri-City Outfall project since it started. I'll turn it over to Keetri.
Good evening. Hi, I'm Keetri Cotton. I'm with Jacobs, and I'm the project manager on this project, and have been working with Wes since 2017 on this.
Great. And at the end of the presentation, we'll have time where Jeff and Keetri can answer your questions about the project. And in the background, we have Camille Pierce. She works with me at JLA Public Involvement, and she's helping with Zoom support. So if you have any technical questions, you can go ahead and send her an email, or a chat directly in the chat to Camille, and she could probably try to help you during the meeting. If for some reason we lose you during the meeting, don't worry, we're going to record. We are recording this, so we can post this, and we'll send out an email link where you can go and watch the recording later. But hopefully we have everybody here for at least the 30 minutes for the presentation. And then we have staff from Water Environment Services. We have Todd Logan, Public and Government Affairs, Alexa Morris, Utility Relations Coordinator, and Shelley Perini, External Affairs. So today, as I said, we are going to give an overview of Clackamas Water Environment Services. We're going to, Jeff's going to give a presentation on the Tri-City Outfall project, and then talk about what's coming up with that project, and then answer your questions. So I'm going to be turning things over to Greg Geist to give an overview of the agency.
All right, thank you, Kristen. Again, my name is Greg Geist. I'm the Director of Clackamas Water Environment Services. And I just want to say we're very pleased to be able to describe this project for you tonight. We're proud of the work that we do in the community. We have a little video that I'm going to introduce here now that describes a little bit more about WES, what we do, and why we matter to the community. Go ahead, Kristen.
I love so many things about Clackamas County. There's so many opportunities for recreation and the people are amazing. But what really sticks out as special for me is the water, our lakes, our streams, our rivers. There's something just magical about water. It's as important as the air that we breathe. It provides our health. It provides our food. It provides our sustenance. We need to make sure that rain that falls on the ground is clean and safe by the time it reaches our rivers and streams. We call ourselves a learning organization. We need to innovate all the time. We always want to try to get better. And for us, a lot of that is connecting with the community, understanding what their values are, what their priorities are, and making sure that we're positioning ourselves in a way to provide that for them. We don't call our facilities sewage treatment plants. We call them water resource recovery facilities because that's what they do. They make clean water, that's very important. They also make energy, electricity, with what goes down your toilet. And we make fertilizer that we can use out on agricultural fields. People expect clean water. They have high expectations around that. And the idea that we can help protect that, and that's our job, how lucky can a guy get to have that be your job?
All right, thank you. And I do feel very grateful to be able to do what we do for the community. And I want to I'll read our vision. We have a vision and a mission statement for WES. And our vision is to be a collaborative partner in building a resilient clean water future where all people benefit and rivers thrive. And as I mentioned in the video, it's all about connecting with the community and understanding what their needs are and what their values are. I'll go ahead and let you read the mission statement. But as I alluded to in the video, we don't just do wastewater. This is a wastewater conveyance project, which means pipes in the ground that get wastewater to our treatment plant for it to be treated and do all the great things that we do there. But we also do habitat restoration in our community and manage stormwater runoff. Next slide, please. And this is the area that we serve. This is our service area in the dark green there. Everything from Milwaukee out to the far reaches of Happy Valley and south down to Oregon City, Westland, and Gladstone. We serve about 200,000 people, and we treat about 7 billion gallons of wastewater every year. It's pretty remarkable. Next slide, please. So what the project that we're talking about tonight, I think we need to give it some context. It's one project of many that we are working on. We base our projects on plans. And so as you can see, since 2017, we've done a number of what we call master plans or facilities plans that take a look at our facilities, the condition and the need for future expansion, amongst other things. And we develop a 5-year, what we call a capital improvement plan, or CIP, based on the needs that are identified in those various plans. This particular project came from our 2019 sanitary system master plan that identified future growth in Happy Valley, as well as some older infrastructure that needs to be replaced. And so that's what we're proposing with this project. Next slide, please. And again, as I mentioned, our 5-year capital improvement plan, which is really the infrastructure projects that we intend to construct, build, and operate over the next 5 years, there's a couple different components to that. Part of it is capacity. This project is about future growth, but the other part is reliability. And when you look at the overall amount of money that we're going to spend over the next 5 years, Between the projects that deal with capacity, that's about 40% of our allocated expenses, and the reliability piece is about 60%. So we have infrastructure that's been in place for many, many decades, and that reliability piece is also very important. Next slide, please. And along those lines, we do a lot of thoughtful planning. We have our 5-year capital improvement plan. You can see the bubble on the left. We also have an annual capital budget. We have a long-term financial plan and a rate forecast. And our goal is to have reasonable and predictable rate increases over time in order to provide both the reliability and the future capacity that we are trying to provide. And again, if you look, we have stakeholder input do loops throughout our process. We have the Board of County Commissioners, which is the governing body of Water Environment Services. They're the ones that approve our 5-year capital improvement plan, and they approve our annual budget and rates that are necessary to fund the capital improvement plan, overall capital improvement plan, and this project in particular. Next slide, and I'll hand it off to Jeff to talk more about the details of the project. Thank you very much.
Excellent. Thank you, Greg. Next slide. So we'll start off with what is the Outfall project? The treated water from the Tri-City Water Resource Recovery Facility is called effluent. This treated water, or effluent, is sent to the Willamette River through an outfall pipeline. This pipeline has diffusers at the discharge location that are designed to maximize mixing of our plant water into the river. This mixing and dilution is carefully engineered as an important component to meeting the state water quality standards, helping improve our rivers for boating, swimming, fishing, and aquatic resources. And as someone who enjoys exploring our rivers, I think this is very important for me personally, and also a very important aspect of this project. The project overall will consist of building a 90-inch diameter, which is 7.5 feet. And I guess think Shaquille O'Neal could stand up inside our pipeline. That's how big this will be on the inside. This pipeline will run from our Tri-City Water Resource Recovery Facility out to the Willamette River, downstream of the Abernathy Bridge, adjacent to John Storm Park. WES will continue to maintain and own the existing outfall to meet the anticipated flows that will come to the Tri-City Water Resource Recovery Facility at build-out, or this is all sized for approximately 2080 flows. Next slide. So why is the outfall project needed? Our existing outfall was constructed in 1984 when the original plant was built. During the recent update to the sanitary sewer system master plan that Greg talked about, a hydraulic model was created to evaluate not only the piping out in our collection system, but also to project what flows we could expect to receive from that piping at our Tri-City Water Resource Recovery Facility. As part of that plan completed in 2019, the need for the new outfall pipeline was identified, as our existing outfall is at capacity during peak wet weather events. At the conclusion of this project, WES will have 2 outfalls to the Willamette River. The new outfall will become WES's primary, as the selected location provides a deeper location in the river, which provides better mixing of our effluent with the river. The existing outfall, which is in still great condition, will remain in place for use when significant wet weather events occur and we need the extra capacity. This will provide us resiliency and redundancy to our outfalls, which is a luxury for our facility. Next slide. The first phase of the Outfall project was to complete a routing study to determine a preferred pathway from the Tri-City facility to the Willamette River. I will note that the Clackamas River, which is right adjacent to our facility, was not an option, as the DEQ does not allow any additional outfalls into the Clackamas River. So we had to target the Willamette. To start this routing study, an analysis of the Willamette River was completed to identify a target location for our pipeline to end in the river. The preferred spot in the river is a deep spot, which allows for better mixing, and a very stable river bottom, which is better for long-term maintenance. We want to assure that once our pipeline is built, We have the depth to allow complete mixing, and that the diffusers will not be buried over time by silt and sands. After looking both upstream and downstream of the Abernathy Bridge, we used surveying the river bottoms. We targeted a location and selected it, which is adjacent to John Storm Park. We then spent time finding the path from the plant to that target, which is shown in the red, blue, and purple lines above. We broke this alignment into 3 segments, as each segment had unique constructability details to work through during design, which Keetri will dive into in the coming slides. And the next slide. But before we get going and talking about all the segments of the outfall, I want to mention a little bit of information on our Tri-City Water Resource Recovery Facility. The Tri-City facility was built in 1984 and treats wastewater flows from Gladstone, Oregon City, West Linn, Happy Valley, and other areas of unincorporated Clackamas County. There was a major expansion completed in 2012, which added capacity using a membrane bioreactor. Construction of this outfall will begin where treated water from these 2 processes combined and are ready to be sent to the river. And with that, I will turn it over to Keetri, where she will take a closer look at the 3 segments I mentioned and talk about some of the unique features of each segment that make up this project.
Thanks, Jeff.
Great.
And just a reminder to the audience that the presentation, we have about 10 more minutes and then we'll have Q&A.
Thanks, Jeff. Thanks, Kristen. So yeah, I wanted to talk a little bit about these 3 segments. You know, we split the alignment up in these 3 segments, mostly based on construction approach. So the first segment is an open cut construction. The second segment is a tunneled construction. And then the third segment is an in-water construction. So I'll talk first about this open cut construction. So the open cut segment consists of construction in Agnes Avenue, and it's going to require careful placement of a new 90-inch fiberglass reinforced pipe on the edge of the old Rossman landfill and adjacent to 2 large diameter pipelines in the alignment that you see here on the picture. And so the 2 large diameter pipes include the existing outfall and the existing force main that need to stay in operation during construction. So the contractor is going to have to protect the existing lines from potential settlement or movement during construction, and they'll be using shoring. And as an example of this type of construction is shored construction is shown here on the middle picture of this slide. So the installation will include excavation of existing soil, and because the pipeline alignment is close to the existing landfill, there may be some landfill material that needs to be excavated out of the trench. And then there'll be careful placement of bedding under the outfall pipe. Some sections of the alignment of the installation may require piles supporting the pipe to ensure that the pipe won't settle over time. And the open cut construction is anticipated to take about 7 months, including 2 months of basically reconstruction of Agnes Road, and also a tie-in at the mixing box at the Water Resource Recovery Facility. Next slide. So I'm going to talk a little bit about the tunneled construction, and as shown on the blue line here on the figure, the alignment starts, that tunneled construction starts near the roundabout at Main Street and ends in the Willamette River by segment 3, where the diffuser starts. So the alignment of the outfall navigates down a tight corridor, a busy corridor between Main Street, I-205, and then it's on and off ramps, and then residential property, a hotel, shopping area, and John Storm Park. So the only way for this outfall to get to the river is that this segment be basically constructed with a trenchless approach. So by hiring a specialized trenchless contractor, Wes ensured that the design led to a constructible approach. The trenchless construction is going to use a large microtunnel boring machine that's depicted here on this picture. It's 108 inches in diameter, and it will allow to get from the end of segment 1 to the in-water portion with a horizontal and vertical curve as shown on the plan and profile on this slide. And so it'll basically allow the alignment to be done in one stretch without having shafts in the middle of the alignment. Next slide. So the project required significant stakeholder coordination with ODOT, given all the crossings at ODOT that we discussed, with the on-ramps, off-ramps, and then, but also because concurrently to this project is the Abernathy I-205 Abernathy Bridge widening projects. So other stakeholders were also involved. Obviously, over these past few years, we talked with property owners along the alignment, the tribes, and then the City of Oregon City and the federal and state permitting agencies for this project. The tunnel construction avoids major highways like I-205 and Highway 99. It also avoids main roads like Clackamas Drive and Main Street. And it also avoids underground utilities, residential areas, and cultural resources. Finally, the project avoids impacts to John Storm Park by going under the park rather than open cutting the shoreline. So the tunneling will minimize the duration of the in-water work by extending the tunnel section all the way to the start of the diffuser in the Willamette River. And that the microtunnel boring machine will basically be able to navigate through challenging ground conditions deep below the surface, and really while minimizing impacts to this busy corridor. Next. So the microtunnel boring machine is going to require an entrance shaft that will be constructed between Main Street and I-205 on West property. The picture on this slide depicts an example of a tunnel entrance shaft, and the contractor anticipates a 30-foot wide by 50-foot long and 25-foot deep entrance shaft for the microtunnel boring machine. The shaft will also allow the contractor to feed individual segments of pipe that will be pushed through the tunnel from this entrance portal. Once the microtunnel boring machine reaches the location of the diffuser in the Willamette River, it'll be retrieved by a marine contractor from the bottom of the river and lifted onto a barge. The tunneled installation is anticipated to take 7 months, including excavation of this entrance shaft. There's a picture on the slide that to the right that shows the type of material that we anticipate finding in the alignment. So this microtunnel boring machine cutter will be able to grind through these gravel soils. Next slide. And finally, the last segment, which is also a really important segment because it will install the diffuser. So this segment will be constructed in the Willamette River. The in-water construction is permitted to occur only during the in-water work window, which in this reach of the Willamette River spans from July 1st through October 31st. So segment 3 will connect the end of the tunnel portion to the outfall of the outfall pipe to the final segment in the river, which is referred to as the diffuser. The two pictures on the right of this slide depict what a diffuser, an example of what a diffuser looks like. So it consists of a main pipe with risers with tight flex diffuser valves on the end. And those valves kind of basically will stick up slightly up from the bottom of the river, and they passively open to allow flow from the outfall pipe to mix into the river. So the in-water work construction will be completed by an experienced marine contractor, and they'll retrieve that microtunnel boring machine that we talked about earlier during the first in-water work period, which will be this year in 2024. And then the contractor will come back next year during the in-water work period of 2025 to install the 150-foot long diffuser. So why are we splitting? Why is the contractor splitting this up into two periods? Because it basically creates a shorter time for them to be in the river, and the benefit of that is that it avoids impacting the I-205 bridge widening project. So careful coordination really has been going on for several years between WES and ODOT actually over the last 5 years to ensure that overlapping construction schedules are feasible and coordinated between the contractors for both major projects. So the in-water work construction overlaps with the ODOT Abernathy Bridge widening, but we also we talked about potentially doing it later, but the benefit of it overlapping with ODOT's bridge project is also that it'll reduce the amount of in-water work seasons that will be in the Willamette River. So it minimizes, it avoids prolonging the impacts to boaters and fishermen in the area. The marine contractor is going to construct this project in a way that's going to be protective of the river's water quality. And it's anticipated to last 1 month for the retrieval of the microtunnel boring machine the first year, and then a couple months in 2025 when the contractor will install the diffuser. And on the next slide, Jeff will discuss the overall project schedule. Jeff?
Sure. Thanks, Kitri. Work began on this project, as I mentioned before, in 2019 with the routing study, followed quickly behind by preliminary design. Due to the unique geology for this corridor that was selected, we decided to deliver this project using a progressive design build delivery model, which brings the contractor on board during design, which really helps you dive into the construction means and methods and manage risk. A contractor was selected in the fall of 2022, and construction will start this spring and will be completed in October of 2025, when our new outfall will be brought online and will begin to serve as our primary outfall. As Kitri mentioned, due to the construction work taking place adjacent to our project area in the Abernathy Bridge, we will build this in-water pieces of the project over 2 in-water work windows, tunneling to the river this summer and building the diffusers next summer. That's why you see the gap in construction, where we're not anticipating any major construction activities. Next slide. And then, so what's coming soon? So we've talked about the overall construction schedule, but I did want to take note of a few activities that will be occurring in just these coming months. Michaels, who's our tunneling contractor, will be moving onto the site. They started dropping tools this week and will continue to move onto into the construction area over the coming month. Once erosion control permits are in hand and received by DEQ, work will begin to prepare the staging area adjacent to the Tri-City Water Resource Recovery Facility, where these 90-inch pipes will be delivered before they're dropped into the tunnel. We're expecting this to be 10-foot sections of pipe. The weight of these pipes, you basically get 1 segment of 10-foot pipe per truckload, and there's over 200 segments to be delivered to our facility. So it'll be exciting seeing that come onto a site. Construction of the tunnel launch shaft will begin in March, with tunneling to begin in July, and our machine should reach its destination in the Willamette River in October, where it will be lifted out of the river and put on a barge. Construction of segment 2, the open cut work, is anticipated to commence in May of this year and run to the end of the year, with reconstruction of Agnes occurring this year. And with that, next slide, I'll turn it over to Kristen.
Great, thanks Jeff and Kitri, and Greg too. So we're going to, we finished up in 30 minutes, just as we promised, and we're going to take time for questions. We're hoping to get questions coming in through the chat. If for some reason the chat doesn't work for you, you can indicate to Camille and we can turn your audio on, or we could bring you in to ask a question. But ideally we can collect all the questions from the chat. I have one more slide that has contact information, and we will go ahead and put this webpage in the chat. Camille will broadcast that out to you all. so that you have that. And then we'll probably end at that slide too after we do some Q&A. So I'm going to go ahead and stop sharing my screen, and then we will go through some of the questions coming in the chat if we have any. I haven't checked yet. So I'm going to stop sharing my screen, and then Camille, I might have you go ahead and take a peek if folks are asking any questions.
No questions in the chat at this moment.
Great. So we did send out the webpage address, and then if you have any email questions that you come up with later, Todd Logan collects the questions and comments through the webpage. You could email him directly if needed.
We do have a hand raised here. So I can go ahead and allow William to talk, and he can ask his question. Go ahead, William.
The chat says it is disabled. I had prepared some questions to paste in there, but I can't paste them in there.
Okay, well, go ahead and why don't you ask your first one, and then Camille's going to check on that. Were you putting them in the chat or the Q&A?
The chat.
Okay.
My first question was, looking at Agnes Avenue, one sees an obvious history of sinking and shifting. What precautions are being taken to prevent future such activity impacting the underground outfall pipe along that same route?
Thanks, William. I can answer that one. So the pipeline will be supported. There's two methods with which we can do this from an engineering standpoint. We can over excavate the refuse that's underneath and replace it with pipe bed material, which will support our pipeline. If in some areas, if the refuse is too deep, we will drill a pile down into solid ground, and we will put a cradle around our pipe and support it in those areas. One of the nice things I will say about when we're done with this project, the areas above the existing pipes and the areas above our outfall pipe should be nice and stable, and we should not see as much settlement occurring out in the road as we've seen currently. And there's a private west property road, and so it's not a public road, but it should be better for walking. It won't have as much of the relief.
That's great, because I've walked it many, many times. I always thought it was a county road, but I think that they've just enabled West to take care of it. My second question says, how long will, or how will we know if the micro tunnel boring machine reveals any archaeological artifacts of importance?
And I can take a stab at this one, and if I'll open it up to Keetri if she wants to follow along. So the machine, there was an archaeological study done of our corridor in coordination with the tribes to look for those in any particular sites that might be of interest. The layer that we are tunneling through as we approach any of these areas, we are down into the second layer. So we will, I guess the answer in general is we're going to be much deeper in any areas of concern than would have been dug by any of the tribes that might have used the Clackamas and Willamette River.
Yeah, perhaps I was thinking not just of tribal artifacts, but any sort of fossil remains, or of possibly, I don't know if you could imagine civilizations, pre-tribal civilizations, but you never know what you're going to find down there, and how will you know what you don't know?
Keetri, do you have an add-on to when the screenings come back from there, what they're removed from the water before it's put back through?
So I think yeah, we'll be, the tunnel section really gets into the deep layers of the ground, into the gravel layers, and I think they're the screenings do come back through a sorting machine, but they're just so fine that there would be a lot of mud in there. I think we're just in such a deep area of the river. We have an archaeologist, and we've gone through archaeological review and of the project. And I think, we haven't really come up with any concerns given how deep we are that we would run into anything there. And I think it's going to be very difficult with the way the tunnel boring operation is run to be able to see anything except gravels coming back through the operation of the tunnel boring machine.
I have every confidence that you've done everything possible to prevent something like that happening. I was just curious that if something does come up, how you would be able to identify it. It sounds like it's not going to come up, so you don't need to identify it. I am curious about when that tunnel reaches the river bank. It seems like there's going to be a pretty big inflow of water coming in there. How do you stop that water from flowing back up into the pipe?
Good question. Do you want to take a stab at it, Jeff, or do you want
Go
me
for
to
it, Kitri. I'll let you answer this one.
Yeah, so the tunnel boring machine will come to the location of the diffuser, and that tunnel boring machine will be deeper than the bottom of the river. So we'll need to excavate excavate the area where that boring machine is going to land, and then take that tunnel boring machine out of there. And once that pipe will always equilibrate with the river once the diffuser is constructed. And at some point when everything's connected, the outfall will always be basically full of water, mostly effluent water from treated effluent from the plant. But in the beginning, there will be some water from the river in the pipe as it equilibrates with, the groundwater levels in the.
Say that word again, please. Equilibrates?
Yes. Yeah.
I love that. That's a great word. Equilibrates. I'm going to write that one down. Okay. Yeah, I think I understand that. It's a hell of a project. I'm proud of us doing it. Looks like we got a good team here.
Thanks, William. I think that we have fixed the chat function. So if there's any other questions, you can raise your hand and we can bring you on screen like we did with William, or go ahead and put a question or a comment in the chat. We will get to that. I think I actually need somebody to test it just to see if it works. So we need a question or a comment.
Those are good questions, William.
Perfect. It's working.
I just tried it. That's what I just read back to you, but just for a test.
Great. Angie has a comment here. What environmental studies were done? How will you ensure the environment is considered?
So along the corridor, there is wetland investigations since we're disturbing the ground. And then in the river, there is an engineering study that's completed around water quality, and it looks at what our discharges to the river will be. It's modeled from the stream and also from the matching up with our NPDES permit and what we will be allowed to discharge into the river. I hope that answers your question. Around the environmental studies, the environmental permitting process is a 18-month process we've navigated through getting all the permits to build this. And so Keitra, I don't know if you want to add any on the permitting side from environmental approach.
We've been working on this project since 2017 and have done a lot of work characterizing wetlands and species in the area, and just making sure that everything was covered as we approached the permitting process. And the Corps took over jurisdiction of this permitting, and the Corps obviously consults with a number of agencies, and including NIMS, all the fisheries agencies, and SHPO and the archaeological agencies. So in the end, yeah, there were a lot of studies that were done, and we made sure that the project went out for public review, and I think we addressed everybody's potential questions with all the studies that we completed.
Great. There's a question here from Lynn on explaining, will you please explain the purpose of the in-water windows? Is it to protect migrating salmon?
Yes, and so thanks, Lynn, for that. The in-water work windows that Kitri mentioned, which run from July to October, is a Department of Environmental Quality, DEQ, rules set up that identifies times in the river where we can work in the river without impacting any of the migrating fish that migrate through the river. And so those are times where they're not spawning and they're not migrating through. And so it's a very limited window every year where you can do in-water work to make sure that we protect our migrating fish and continue to have wonderful fishing in our rivers.
Thanks. Greg asked, how deep is the excavation in Agnes Avenue?
And I'm going to let Kitri jump on that answer if she knows it off the top of her head, but it's 8 foot. The pipe is 8 feet, and there is another 12 feet above that. And so it is roughly about 20 feet deep to the bottom of the trench that we'll be installing. So it's about 12 feet of cover on that pipeline. It's a very deep excavation in Agnes, and it will open up a broad swath of it.
Yeah. William had asked how many people are attending the presentation. At the most, we had about 12 in here while the presentation was going on. A few folks have dropped off, and I think we had about 30 register, or maybe 25 register. So about half the people attended. See, John asks, does the boring machine have a name already, or can we name it?
So it is something that we are working on as an organization right now to do some public outreach. Thanks for this question. Kitri, you can look at the next two and start to get answers to those. But John, we will be working on probably a survey that'll go out to the public to solicit input from a list of names, and we'll let the public vote to give us a final name for our machine. And you can expect that outreach to happen in the next month, as we kind of have a deadline of March to have the machine named, so we can make sure that we get logos and things put on the machine. And we will have some public outreach as well when the machine arrives on site, and a kickoff to the overall tunneling part of the project, which is a really unique and exciting part of the project.
Let's do the last question that John had. How fast does the contractor figure the tunnel machine will move?
So the tunnel boring machine will progress basically for, it's got about 2,500 lineal feet to go between the beginning of Agnes, the end of Agnes Avenue there at the Main Street roundabout, all the way into the Willamette. And the initial ground conditions are a lot more favorable for the microtunnel boring machine, so it's likely to move faster through that area than after it dives into the deeper grounds, which are that layer in the soil is made of more gravelly soils. And so those production rates may slow down as the contractor gets into that layer that takes a little bit more time to grind through and make it to the river. But overall, and I can't tell you how many feet per day, but overall those 2,500 feet will take about, so they'll start in May and they should be done by October. So we're looking at, May, June, July, August, September, 5 to 6 months, and then they'll take about a month to retrieve the tunnel boring machine from the river.
It's
and
approximately,
there's a on the front end, sorry for that big shaft construction.
It's a 15 to 20 feet a day on average.
Thanks, Jeff.
And once we start tunneling, it is a operation that once you start, you don't stop until you reach your destination. And so it will be an operation that's kind of 24/7 driving that, working in that tunnel out that direction.
And Kitri, John had some questions also about the pipe. How will the segments be connected, and then how far away the pipe is manufactured?
Yeah, so the pipe segments are I'll talk about the pipe itself. The pipe material is a fiberglass reinforced pipe. And in the in the open cut, those segments it'll be easier to connect those joints together because it's all exposed and open cut. As you're going through the tunnel, the pipe is different. It's still a fiberglass reinforced pipe on the inside, but on the outside it's a cement, almost like a cement coating, but it's 108 inches. So you've got this thickness of concrete on the outside, and the pipe connects through a special connector that a hydraulic connection almost that ensures that the pipe is tight at each of the joints. And then in the river, it's yet a different connection between the segments. They'll be either bolted together in depending on the flange connections. So different and then the last segment of the pipe in the river is actually a steel pipe with a concrete coating and lining for the diffuser to be really sturdy in the bottom of the river. So different materials or different types of pipes as you go through, but mostly fiberglass reinforced pipe from the beginning of at the plant all the way into the river. And then how far away is the pipe manufactured? It also depends on the segments of the pipe that you're looking at. The contractor is still working on ordering the pipe and figuring out the best cost-effective way to get pipe to the project area. Some might be manufactured in our backyard, and some might come from a little bit further away.
Right.
Jeff, did you want to add anything to that?
Nope, that answered it well.
Thanks. Angie asked about the lifespan of the current pipe, and what about the lifespan of the new pipe?
Sure. Our current pipe has been in the ground for 40 years, and if we didn't need more capacity or didn't need to put the effluent into a better spot in the river for mixing and water quality, we could continue to use the existing pipeline. So we're designing this new pipeline anticipating being in service through 2080, so 50 to 60 years is our anticipated expectancy of it. And because this water is treated effluent, it's not very corrosive, and it's real suitable for being having a very long life of this of the pipe. But we're designing it for a size that's 60 years from now, and so the anticipation is it will still be in service at that point.
Right.
Those are really great questions. Thanks, everybody.
What about earthquake-proof seismic considerations?
So there's not we do not specifically design. We have not designed specifically around an earthquakes for resiliency on this pipeline. There are aspects of it because of the construction technologies that'll probably perform very well, but overall, there was no design earthquake evaluated for this infrastructure.
Yeah, and I guess, Jeff, I would just add that, typically outfalls are not constructed actually to be earthquake proof. You try to give them some, if you can accommodate for some resiliency, you do, but generally, the cost of doing that is so significant that it's not worthwhile in the sense that, usually the rest of the system ahead of the treatment plant is not earthquake proof. So, some components might be, but you look at all the piping that brings all of the flow to the plant and then the plant itself. So most outfalls in the Northwest are not built to be earthquake proof, if that makes sense.
Do we have any other questions that folks want to ask?
Yeah, great questions. It's been
Yeah,
really
really
nice to see people interested and engaged in the question.
And I'll just put a plug while we have some calm here. Our intention is to continue to update our project webpage with photographs and information along the way as we build this. It's a very unique project. The size of and adding in the tunneling, which is really exciting. So we plan to continue to update our Outfall website with additional information and photos as we build this pipeline. So make sure to go back and check on the webpage and check for updates.
And has there been consideration of making this project to the CIC?
And I guess maybe you can, I don't know that Citizens Involvement Committee. Thank you, William. We go ahead, Greg. Looks like you're going to answer.
Oh, no, go ahead, Jeff. Sorry.
We have a number of presentations. We currently don't have one scheduled with the Citizens Involvement Committee. But William, if you think that's worth, let's have some conversation offline, and I'd be happy to come and give a presentation about the Outfall.
And Alexa, who's on the call here, she's listening because she and I will be helping Jeff to schedule presentations and for folks who want them. So we can have opportunities to do that over the next months, even over the next year as there's more photos. But as Jeff said, the website will also be updated and this presentation will be posted to the website. Camille, why don't you go ahead and post the put the web address again in the chat. Question, will there be audible noise during the drilling?
So the tunneling occurs, most of the noise of the grinding and the tunneling will occur below ground, underground. We do expect there to be some small noise, moving pipe and doing different things, but it's not I don't anticipate it to be a loud project since it is a 24/7 operation.
We have about 10 minutes left that we're scheduled to be here. The questions have died down a little bit, but we'll be here. So, but we can let folks have their evening back if we, can say thank you all for attending. And thanks to Jeff and Kitri and Greg for providing us with all of the information. The web page has been put into the chat, and then I will share screen again just so that you can see the web if you want to grab the address off there, if you can't open the chat where you're at. And for some reason, it's taken me a while to do it. So here is the webpage. And if you go to the webpage and you scroll down to the bottom of the Clackamas West projects page, go down to the very bottom and you can sign up to get Wes email updates. And then you can click on the Tri-City Outfall project and then you can get all of the information about this project. And then in about a week, we would have this presentation posted to the web. So Thank you all for attending, and we will stay on for just a couple more minutes, but if folks want to get a couple more minutes back or have any more questions, we'll wait until time is up to be able to answer those questions. Jeff, I don't know if you had any last words to share.
No, thank you for joining us tonight. It
Thanks.
was a pleasure giving you information and a lot of great questions, and I appreciate the excitement and interest in our project.
Thanks, everyone. All right. I think everybody has left the meeting. So